So, what's the first thought that comes into your mind when I say the word barriers? For most of us, the word barriers generally has quite negative connotations. Most barriers are restrictive, like roadblocks. They make it harder for us to get to where we want to go. But if you look past this, some barriers are actually there to protect us, just like dams are there to stop flooding. Other barriers are more complex, as they are selective, and they can be opened and closed, or regulated by an external signal, analogous to the ticketing system used on the London Underground. In our airways, it is no different. Between the cells lining the airway epithelium are restrictive, protective, and selective barriers known as tight junctions. Now, when these tight junctions are functional, they contribute to the first line of defense against inhaled viruses, toxicants, and pollutants. However, just like the barriers in everyday life, the barriers in our airway can fail us. And when they do, all these inhaled agents can now penetrate the underlying lung tissue, driving inflammation and activation of our immune system, which can lead to chronic respiratory diseases like asthma and COPD. Interestingly, more recently, we've come to realize that barrier or tight junction disruption is one of the first signs that an inhaled drug might not be safe. So, my PhD seeks to address, firstly, what are the tight junctions in the airway actually made of? So just like all the barriers on the slide above are made of different materials, what are the specific proteins that make up the tight junctions in the airway, and how are they structurally assembled together to form this functional barrier? Secondly, just like you can tell that a dam, a protective barrier, is just about to burst by the presence of hairline cracks, I'm investigating what the early signs of tight junction disruption are in disease and in response to toxic inhaled drugs. By detecting these tight junction hairline cracks, I can start to investigate the molecular mechanism of their disruption and potentially reveal potential therapeutics for their repair. So far, by using a type of microscopy known as super-resolution microscopy, which essentially just allows very fine cellular detail to be seen, it is clear that the tight junctions in the airway exist as this intricate, interconnected network of protein strands. So, if there's one thing that you take away from this talk today, it's that the barriers in our airways are vital for protecting us, so it is essential that we prioritize research into their function. Thank you for listening.